In this video, we're going to be going over counters in pooling mode. So here's what we want the program to do. So basically, we want counters 0 and 1 in mode 2. The current count of the counters will be displayed in port 1 and port 2 respectively. We're going to keep track of the timer flags for counter 1 and counter 2, and we're going to display them on port 3 bit 0 and 1. The main program will start at code memory address 40. So the only function of the main program is to update pin 1 and pin 2 and display the two timer flags on port 3. Also, this will be the initial count for the counters because they're in mode 2. And also, the updates will be displayed on every counter's initiated clock pulse. So before we start the program, I'm going to go over about the counters register, the tmod register, and then the modes. So the counters registers or timers registers is a 16-bit register, so it's split in half. One side for T high and the other one for T low, depending on what timer you're using. So for T high, you have 8 bits, and for T low, you have 8 bit. And basically, T high and T low are used differently on each mode. And this is a Tmod register. And the main thing here for this program will be the counter. So in order to configure counter 1 and counter 2 into mode 2, this will have to be the values in tmod register, which is 6 and 6. So to avoid any typos, I'm just going to copy and paste segments of the code and explain how they work as I go. So as the instruction said, the main program will start at memory address 40 hex. So here's where we'll start our code. So the first thing to do is to basically set port 1, port 2 as outputs, and then clear port 3 pin 0 and clear port 3 pin 1 to display the timer flags. So now we get to the tmod. So in order to configure the timers as counters and in mode 2, we'll have to give tmod the value of 66 hex, which in binary will be 01100110. And that's exactly what we need in order to make it into mode and configure the timers as counters. So mode 2 means that it's an 8-bit auto reload. So whatever is in T high will be automatically reloaded into T low after the timer flag. So next we're gonna initiate the values of counter 0. So on T high we'll put the given value in the instructions, which is F5 hex. And for T low we'll do the same thing, but it would only have to be initiated once, which is at the beginning of the program. And then you do the same thing for T high 1 and T low 1, but with the given values that were given in the problem. Next we go ahead and start the counters. Set bit to timer 0 and timer 1. So next we just display the current count of each counter into the corresponding port. And then that'll be the end of the main program. And I will start with the subroutine, which we will call pooling. And we will actually have two parts in the subroutine. One will be to check TF0, and the other one will be to check TF1. So the logic behind both parts is pretty much the same thing. What we're gonna do is we're gonna display the current count of counter 1 into port 2, and I'll go over how that works in a little bit. So then it will be jump if no bit. So if there's no bit in TF0, then it will automatically jump here to check TF1. And the code here is pretty much the same thing, only that we're gonna change this T1. So if there's no bit in the timer flag 0, it would automatically jump here to check TF1. But before we check it, we're actually going to display the TL 0 into port 1 because there was no overflow or the flag wasn't set, so it would just display the current count of counter 0 into port 1. And then pretty much if there's no bit on TF1, it will go back and display the current count of TL1. And you'll keep doing that until there is an actual overflow. And when there is an overflow, we'll set the bit of port 3 pin 0 or port 3 pin 1. And then we will clear it, and then we will jump back to pulling. So the entire program will actually just stay running here. It will keep jumping back and forth from check TF1 to check TF0. And when the bit is actually set, it would set the bit and then clear it, and then it would jump back and continue doing it. So let's see how it runs. So you first have to save it, build project. Yeah, so the way you get this Windows open, if you don't know yet, is through here. So as you can see, let's run it. So as you can see, the actual values of the current count is actually being displayed on the ports. And then we actually clear the pins on port 3. So right now we're gonna try to get this to FF. So now then in the next clock pulse, it should set the pin for port 3 pin 0. And there it goes. And then you continue. However, whenever you're dealing with counters, you don't really want the program to actually clear the TF as we did, or clear wherever you're displaying it. So for example, if you have a machine that is filling up a container and the container gets full, you don't want the program to actually clear the overflow and continue loading the container when it's already full. So yeah, that's about it. There is one thing I forgot. Yeah, but it seemed to work anyways. It was just a warning. But yeah, that's about it for this video, and you could try changing the values or changing the mode and see how it works.